So now we're motivated to look in gravity and see, do we see some features that, that hinted at this? Now, one of the features of gravity that's unique, of course, the one that we mentioned before was the equivalence principle, right? As part of that, if you're falling along in a free fall frame and you see any other freely falling particles, of course, doesn't mean only something that's literally falling, as you say in English. It means something upon which nothing is acting other than gravitation. All right? So it can be a projectile going up. It could be something orbiting. Those are all in free fall, correct? If you are in free fall, in some free fall state, and there's a bunch of other particles in free fall, in all kinds of different free fall motions, but all of them in free fall, what will you notice about their motion? Let's say they're crossing your path. There's an orbit. You're been ejected from the Earth, all right? And you're on this kind of trajectory like this, and there's a particle orbiting right past you, and there's something going up and down, and all these particles, they're all kind of converging, not quite hitting each other, passing by each other. What do you notice about their motion? What does their trajectories look like to you? Not even a world line. Straight line. Because you all have the same acceleration. So you've wiped out all the acceleration. All you're left with is velocities. They have different velocities relative to you, but they don't have acceleration relative to you. Okay? So that is something very unusual, and that already hints at ideas of it being a geodesic. Somewhere there's a geodesic hidden. Another thing, if you have, let's say, an electric particle in a magnetic field, electric field, and you shoot it out at a certain angle, okay? What do you need to know, given the angle? Do you need to know anything else to be able to map this trajectory?
Actually, but may I ask something about this stuff? The acceleration could be different because there are different distances from different.
Yes, right. Okay, that's right. Right. If you're talking about particles that are right near each other, they should all have the same acceleration, but we need a field equation to determine what is causing this warping and how does it affect things at different distances from whatever source it might be. So I would be talking about things that are right near you. Okay? And in this case, just an ordinary gravity, things right near you. So I notice they're straight lines. Now, if I take a trajectory of a particle this way, like this, is that sufficient to map the rest of the trajectory? An electric field. What?
You need the velocity.
You need the velocity. Right. You might need an electric field. You might need, the mass, the charge ratio, all kinds of things to get things going. In gravity, though, is it or isn't it not enough? If I know the initial trajectory.
You ask for free fall,
Yeah, there's only, well, it's not a free fall. Let's say I'm right here on the planet, and I'm ejecting the particle at an angle.
You know the velocity?
Pardon me?
You know the velocity?
Sorry?
Do you know the velocity?
Okay, so the question is, what do you need in order to map out the...
Yeah,
you need the velocity. Okay, is that sufficient if you knew the velocity?
and the angle.
And the angle.
The angle, right? You know the orientation. If you know the velocity is a vector, so you have the angle and the amount.
The initial side.
Okay. Would you know the rest of the... Could there be several different particles with the same velocity and they have different trajectories?
No.
How about if it's an electrical particle in an electric field? Yes. So gravity, part of that uniqueness, another way of looking at it, is that if you have the initial tangent to the trajectory, you can entirely specify the entire curve. That is a property of geodesics. It is not the trajectory which is a geodesic, of course. Okay, it's the world line. But these are hints in gravity. Something is going on here. There's straightness locally, local straightness. The lines are straight even though they're not supposed to be. They're curved trajectories, and yet I see them as straight lines, all these other particles. And I can uniquely specify the entire trajectory given an initial tangent. If you knew about differential geometry, you say, that's basically the definition of a geodesic.